Okay, so heat transfer. We need to finish up Unit 2, thermal physics. When we talk about heat transfer, we have three ways of transferring the heat: conduction, convection, and radiation, or to be more specific, infrared radiation. First of all, when I talk about conduction, okay, conduction is due to the vibrations of the molecules صح have molecules that are vibrating and we transfer the heat using this conduction. So for example, if I have hot water touching another surface of the beaker, for example, so the energy transfers from the hot water to the beaker by conduction because they're touching, because the molecules are close together. Okay, due to the vibrations between the molecules, we always transfer the heat from the high concentration, okay, or from the high temperature, or from whatever, whenever the kinetic energy is more, whenever the kinetic energy increases, to the lower temperature or to the lower kinetic energy. Temperature and kinetic energy are always شباب, directly proportional. As you increase the kinetic energy of a molecule, the heat or the temperature of this molecule increases as well. طيب يبقى in conduction احنا we have والله conduction means ايه او يعني conduction is usually due to the vibration of the او transferring heat, we can say it so, it's a transferring heat by vibration, okay, by vibration through lattice molecules, or we can call it lattice vibration in neighboring molecules, okay, by vibration to neighboring molecules, neighboring, okay, molecules. So يعني دلوقتي I'm transferring heat, احنا we call it sometimes the lattice vibration of the molecules. What's the lattice vibration of the molecules? We can add the word هنا lattice vibration to the neighboring molecules, meaning that the molecules are all together. So if I have a solid, for example, okay, I have a solid. The solid has a lattice structure in which the molecules are all in place, they are all in order, okay, and you start to heat up, okay, this is a larger molecule, and you start to heat up this solid object. Okay, if I start to heat the solid object from this part, okay, so the first molecule will gain a lot of energy, and thus it will transfer this energy to the neighboring molecules by conduction, okay, by conduction through lattice vibration. So the molecules will heat up, okay, the molecules will start to heat up this way, okay, they will start to heat up اهو بنقول ايه lattice vibration neighboring molecules. Okay, and then we have two types of materials, we have two types of objects, either it's a good conductor or a poor conductor of heat. Good conductors are metals. So we have good conductors and poor conductors. Why are good conductors good conductors? Why do they conduct heat quickly? Because they have free moving electrons. Type we need to talk about the free moving electrons. So free moving let's write down first of all what are the good conductors. We know that the good conductors are the metals, okay? Good conductors are metals. And then the second question is, why are metals good conductors of heat? Because they have free moving electrons. So free moving electrons. طيب حلو. And the non-metals, which are the insulators, okay, the poor conductors, we can call them the insulators, صح? Insulators. Why are they insulators? Because they have no free moving electrons. Okay, they lack the free moving electrons. Oh, no free moving electrons. ماشي. طيب جميل. Um, we need to talk about the point, the free moving electrons. Why is this a good thing? Why are free moving electrons, or why do free moving electrons help with the transfer of energy, with the quick transfer of energy? If I have a metal spoon, for example, and I put it inside a cup of coffee or a cup of tea, why does this metal spoon heat up quickly? Why does it heat up quickly? Because it has free moving electrons. Like, what happens in what do these free moving electrons do? Well, like these free moving electrons can travel quickly, okay, they travel quickly between the molecules, and they transfer heat. Okay, they transfer the heat from the high, okay, the high temperature end to the colder end. Okay, they take the heat from the whatever the source, and they take it to the colder part of the metal. Okay, so between molecules by transferring heat. Okay, transferring heat from the hot end to the cold end, from the hot end, to the colder end, to the cold end. Again, if I have a cold object, okay, if I have a cold object and I have a hot object, the difference between a cold object and a hot object is the lack or the gaining of heat. يعني إيه؟ If I have something that's cold, doesn't mean that it has cold energy. لا, it means that it lacks heat energy. Okay, so it's all about a matter of did I increase the amount of energy, did I increase the amount of kinetic energy, or did I decrease it? If you increase it, then the temperature will increase. Okay, if you decrease it, then the temperature will decrease. It's all about an increase or decrease in the amount of energy. Okay, of heat energy, to be more accurate, of thermal energy. Okay, not a matter of increasing or decreasing cold energy. No, that's definitely wrong. ماشي. يبقى conduction, if I have two surfaces that are touching, they will conduct. So solids basically can conduct heat. Solids can conduct heat. طيب, can liquids conduct? Yes, they can. Basically, we have a solids. Solids are the best conductors. Okay, so if I actually want to be more specific, I have two types of solids. I have good conductors and poor conductors. So the best conductors, okay, if I want to say the best conductors, let's write it down. Which the metals are the best conductors. So best conductors. طيب, what about non-metals? Non-metals. Do they conduct? Yes, they do conduct. Are they the best? No, they're not the best. So they're the worst conductors. I won't say that they're the worst conductors. They are worse. Okay, they conduct less. Okay, they are worse. Oh, they conduct less. طب يعني, do you have something that's even worse in conducting? Yes, we have. Okay, so they are, let's say, poor conductors. Poor conductors. Metals and non-metals. Solids. طب what about liquids? ها, والله liquids are even poorer. صح? They are even poorer conductors. So they don't conduct. Okay, they do conduct. Huh? Okay, so don't say that liquids or gases don't conduct. لا, they do conduct. Okay, liquids and gases do conduct. ايه ده؟ طب ما the molecules aren't touching each other, but they can touch each other. Okay, they can hit each other. They can conduct energy through the vibrations in that contact. Okay, whenever they get into contact, they contact each other مثلا, or they hit each other, they will eventually transfer the heat. So liquids and gases, okay, liquids and gases, do they conduct? Yes, they do conduct. But they're even worse conductors than non-metals. Okay, يعني gases are, we can say that the gases are the worst conductors. Worst conductors. طيب, what about the liquids? They're very poor conductors. Very poor conductors. Okay, but you cannot say, okay, you cannot say that the liquids and gases do not conduct. They do conduct, but the percentage of conductivity, that's much less, much less than metals or non-metals. Okay, okay, ماشي. يلا بينا. كده, we talked about conduction. What about convection? Convection. Convection usually happens in gases and solids. صح? Usually happens in gases and solids. Gases and solids. يعني gases and solids يا شباب. دلوقتي, if I have a container, I have a beaker ولا حاجة. Okay, I have a beaker. This is a beaker with some water inside it. You have some water inside it, and I start to heat up the water inside this beaker. Yeah, I'm heating up This is a Bunsen burner, for example, and I'm heating up this water inside the beaker. What will happen? And you'll tell me, well, the hot water will rise up. Oh, the hot water rises up. This is the hot water, hot liquid, hot gas, okay, and the cold water falls down, and the cold water moves down, creating, oh, this is the cold water or the cold liquid or the cold gas. Okay, I'm saying, well, the conduction can happen in gases and solids, in both. In terms of molecules, what happens? طيب الجاسز او الليكويدز they gain kinetic energy صح او liquid او water water molecules water molecules gain kinetic energy and thus increasing the volume okay او increasing the distances between the molecules increasing the distances between the molecules increasing the distances اهو between the molecules So when the distances increase between the molecules, what happens? The volume increases. Thus, increasing the volume increases. Sure. When I say that the volume of the water increases, it doesn't mean that the volume of each atom or each molecule increases. لا. It means that the volume of the water collectively, okay, because the distance between the molecules has increased. Okay, the volume of the water has increased. Why? Because the distances between the molecules has increased, not because each volume or each molecule has increased its own volume. No, that's wrong. طيب, as the volume increases, what happens to the density? You have to say, well, the density, density decreases. Density decreases because the mass is the same. Density equals mass over volume. So density equals mass over volume. As you increase the volume, the density decreases, and therefore, what happens يا شباب? most energetic molecules, أو the hot water. Okay, the hot water rises up and the cold water falls down okay or moves down or whatever. This is what we call a convection current. It happens in gases and liquids, not solids. I do not know how I wrote down solids. Gases and liquids. It can never happen in solids. Okay, why can't it ever happen in solids, Mister? Because in solids the molecules are fixed in their places. In solids, the molecules do not move, or they vibrate in their own places. They do not move freely. In liquids, they are free to move. In gases, they are free to move. In solids, لا, they do not move. They cannot move. طيب يبقى in convection hot water moves up and cold water moves down. There is no such thing as sideway convection. Any sideway convection, okay? No sideway convection. يعني no sideway convection يعني hot water can't move to the left or to the right or خلاص or cold water cannot move to the left or to the right. It's only either up or down. يبقى only the hot water moves up and the cold water moves down. Okay. ماشي. No sideway convection. It happens only in gases and in liquids. حلو جدا. No, that's it. Yes, that's it. No, that's it. Convection is easy. It comes a lot. We have a lot of questions regarding the convection. فيعني it's quite interesting. ماشي. The last one is the radiation. Okay, the radiation. What's the radiation? To be more specific, you need to say infrared radiation. Okay, you have to say infrared radiation. Infrared radiation type. Why do I have to say infrared radiation? Because we have several types of radiations. We have several types of radiations. For example, if I talk about the sun emits mainly three types of radiations: infrared radiation, light radiation, okay, and ultraviolet radiation. So never say just radiation كده وخلاص. لا, you have to be very specific when talking about the radiation. In our case, we're talking about heat transfer. If I want to transfer heat, I will transfer it using infrared radiation. One of the types and one of the ways in which we can transfer heat would be by infrared radiation. So for example, the sun, it sends heat to the earth, صح? طب how does it send this heat to the earth? Using infrared radiation. It is the only way, okay, in which heat can be transferred in a vacuum. In a vacuum. So infrared radiation is basically a wave. It is a wave, an electromagnetic wave. It's an electromagnetic wave. Okay, magnetic wave. It has a speed of 3 times 10 to the power of 8. السبيد كام؟ 3 times 10 to the power of 8 meters per second. It's an electromagnetic wave. It can travel in vacuum. It's the only way in which we can travel, or in which we can transfer energy, heat energy in space. Can travel in vacuum. Travel in a vacuum. So basically, if we have a vacuum, okay, for example, the vacuum flask, ولا مش عارف إيه. This vacuum flask, it prevents, okay, vacuum, it prevents the heat transfer by conduction and convection. If I have some vacuum, it will prevent, definitely it will prevent the heat transfer by conduction and convection, but it only transfers heat by infrared radiation. So basically, you can never stop, okay, you can never stop 100%, you can never completely stop the heat transfer. The heat will be transferred whether you like it or not. It will be transferred either by conduction or by convection or by radiation. If you stop the conduction and convection, okay, by using a vacuum, it will be transferred using the infrared radiation. I need to see how can I increase or decrease this rate of transfer, this transferring of heat using the infrared radiation. Okay, we need to see how can we control it. Controlling it, I need to control the surface of this object, of the beaker, of whatever. You need to control the object, outer surface of this object. How can I control the outer surface of this object? Either I will color it dark black or shiny white. Either the color would be dark black, dull black, I'm sorry, not dull, dull black, or it would be shiny white. Type. What's the difference between dull black and the shiny white? Well, like dull black is the best. It's always the best. It's the best emitter of infrared radiation. It's the best absorber. Absorber of infrared radiation. Okay. طب what about the shiny white? لا والله, the shiny white is the worst emitter. It's the worst absorber. Worst absorber. And in some cases, okay, you can say that the best is the dull black is the worst reflector. It's the worst reflector. Okay, and the shiny white is the best reflector. Best reflector. حلو. يبقى dull black and shiny white, difference ما بينهم, the difference is that the dull black is the best emitter and best absorber. Worst reflector. طيب shiny white, worst emitter, worst absorber, but it's the best reflector. When do I say that an object is an absorber? Either it's best or worst. And when do I say that an object is an emitter? Again, either best or worst. It depends on the temperature of the object compared to the environment around it. بصوا كده, again, it depends on the temperature of the object compared to the environment around it. The same object with the same temperature, بصوا, the same object with the same temperature could be an absorber in a certain environment, and it could be an emitter in another environment. So for example, if I have a cold cup of water, okay, I have a cold cup of water, water, and it's hot outside. I have a cold cup of water and it's hot outside. So this cup of water compared to the environment would be an absorber. Why? Because it wants to absorb infrared radiation. Okay, it wants to equalize and it wants to become equal. The temperature of this water, the amount of energy inside this water, it wants to be equal to the environment around it. So if I have a cup of water in a hot environment, خلاص, in the summer or whatever, it would be an absorber. This same cup of water, the same cup of water at the same temperature, if I put it inside the freezer, the same cup of water with the same everything, and I put it inside the freezer, it wouldn't be an absorber anymore. It wouldn't be, an absorber anymore. In this case, if you have the cup of water and you put it inside the freezer, it would be an emitter. It would be, an emitter. Why? Because compared to the environment around it, this cup of water has more energy. The temperature of this water is greater than the environment around it. So it depends on whether the temperature of this object is greater or less than the environment around it. If the temperature of the object is greater, then it would be an emitter. If the temperature of the object is less, it would be an absorber. Okay? It would be an absorber or an emitter. طيب. Let's take a couple of examples. Okay, let's write down a couple of examples. Some are two very famous examples to determine whether I have a good absorber or a good emitter or a bad absorber or a bad emitter. طيب, let's see. Example number one. I have a beaker, okay, whatever. This is a beaker. Let's say it's a beaker or a container, okay. This is a container with hot water inside it. Inside it has ايه شباب, hot water. حلو كده. Container has hot water, which means that this container is now hotter than the environment around it. It's hotter than the environment around it. So this container would be an emitter. صح? This container has hot water, which means that this container is hotter than the environment around it. Its temperature is greater, higher than the environment around it, so it is an emitter. So this test, I am testing, okay, I want to find the difference between a good emitter and a poor emitter or a bad emitter. Okay, this test, I want to test the difference between good and bad emitters. Bad emitters. طيب. يبقى how can I differentiate between them? Simply, all I need to do is color each side using a different color. One of the sides would be, let's say, shiny white. So this is colored shiny white. And the other side would be colored dull black. يلا, this side would be dull black. يبقى I have two sides, shiny white and dull black. صح? Two different colors. One of them should be the best emitter and the other one should be the best emitter and the other one would be the worst emitter. In this case you cannot say absorber على فكرة يعني. If you have this example in paper 4 or paper 2 or whatever, and you say that this is an absorber, or for any reason you wrote it down without even thinking, you wrote a best absorber or best or worst absorber, that you will lose a mark. This is a case of emitting infrared radiation. طيب, I have a shiny white and dull black surface. I need to measure equal distances on each side. This is a distance of whatever, 5 centimeters or 5 or 10 centimeters. Okay, you have equal distances on each side, and then you have thermometers. Okay, let's assume that this is a thermometer. I know that يعني, I'm one of the best illustrators out there, I know, but يعني, let's assume that this is a thermometer. Okay, and you have two thermometers on one thermometer on each side. Okay, you'd find the thermometer. Which thermometer would have a higher temperature with time? تقولي والله the thermometer on the left. Okay, the thermometer near the dull black surface. Okay, that's the answer. You would say the thermometer, okay, near the dull black surface, would have a higher temperature. Why would it have a higher temperature? Temperature. If we leave them both, for example, for 5 minutes or whatever, okay, the thermometer on the near the dull black surface would have a higher temperature. Why? Because dull black dull black is the best إيه in this case we would say it's the best emitter is the best emitter not of heat. You cannot say that it's the best emitter of heat of a infrared radiation of infrared radiation. Dull black best emitter of infrared radiation. خلاص you cannot say it's the best emitter of heat. You cannot say it's the best absorber. ايه ده يا مستر؟ طب ما I know ان dull black is the best absorber. I know, yes, it is correct. But for this question, for this example, you have to say that dull black is the best emitter of infrared radiation. Why? Because it's emitting. It's giving off infrared radiation. The amount of radiation, the amount of infrared radiation given off by the dull black is much greater than the amount of radiation given off by the shiny white. Shiny white, it is giving off some infrared radiation. Again, see, you cannot stop the infrared radiation. Even if you add a shiny white surface, even if you add whatever خلاص the shiny white surface and a vacuum or whatever, but this shiny white surface again cannot prevent. Okay, if you write down that it prevents, for example, yeah, if you write that the shiny white prevents infrared radiation, that's wrong. You would lose a mark. Shiny white doesn't prevent. It reduces. We can say it reduces the amount of radiation or the amount of infrared radiation being produced or being emitted by this hot water. But never say that the shiny white prevents. لا, it doesn't prevent. It can reduce. Okay, it doesn't prevent يا شباب. طيب, these are this is an example to determine the difference between good and bad emitters. طيب, can I give you another example relating the difference between the good and bad absorbers? Yes, I can do that. يلا, let's write it down. Good and bad بس المرة دي absorbers. Good and bad absorbers. So in this case, in this case, I will have a heater in the middle. Okay, I will have a heater in the middle. Okay, for example, this is a heater or whatever. I don't care about how it looks, بس يعني this is a heater. يلا, with a coil around it producing this heat. حلو, this is the heater. حلو. طيب, on again we leave equal distances on each side. You have to leave equal distances. This is an experiment. You have to make sure that the numbers are equal. Okay, that the controlled variables are the same. صح? And on this side I would have a beaker. Okay, with cold water this time. A beaker with cold water and a thermometer inside it. Okay, and you have a thermometer in the beaker. Again, on this side you have another beaker with cold water as well. يلا, cold water, the same volume of water, same initial temperature of water. Okay, and a thermometer inside it. The only difference between these two beakers would be the outer surface. Okay, would be the color of their surfaces. The beaker on the left would be painted dull black. Okay, it would be painted dull black. Oh, dull black, and the beaker on the right would be shiny white. Okay, and I leave the heater on for a couple of minutes, 5 minutes or whatever. You'd say, well, like the dull black, the beaker on the left side would have a higher temperature. So the beaker on the beaker on the left side would have why is this a B? It should be an H. Would have a higher temperature. Why does it have a higher temperature? Would have a higher temperature. Why? Again, you have to say that the dull black is the best. صح? dull black is ايه يا شباب? Is the best ايه بقى? Is the best absorber in this case. Again, of ايه بقى? Absorber of infrared radiation. يلا, infrared radiation. Okay? A dull black is the best absorber of infrared radiation. The previous example, it was the best emitter of infrared radiation. In this case, it's the best absorber of infrared radiation. خلي بالكم, the heater is giving off the same amount of heat or the same amount of infrared radiation on each side. يعني it's giving off the same amount of infrared radiation هنا and the same amount of infrared radiation on this side. But the amount of radiation that can be absorbed by the dull black surface is much greater than the amount of radiation that can be absorbed by the shiny white surface. And hence, the temperature of the dull black or the container painted dull black would be much higher. ماشي. سهل الكلام. Easy. طيب. Last but not least, we need to talk about the flask. The vacuum flasks, which is a very famous example على فكرة يعني. A vacuum flask. يلا. Vacuum flask. If I want to design a flask which can keep the temperature of which can keep the temperature of the water high or low, على فكرة high or low for a longer time, I need to have this flask designed with يعني some specifications. Okay. طيب, what are these specifications of this flask? تعالوا نرسم كده this flask. Don't know why it has a very weird nozzle, but it's okay. Yeah, it's we call it a vacuum flask. So between these two surfaces, we would have a vacuum. Between these two surfaces, you have a vacuum. You know? Yeah. حلو كده. Okay. I know it's a weird looking flask, بس معلش. Yeah. And this flask would have a stopper. Okay. It has to have a lid. It has to have a stopper or a lid. This stopper or this lid should be made of what material? You have to say that this stopper or this lid has to be made of a non-metal, an insulator. يبقى this stopper, it has to be made of, preferably it to be made of an insulator. It should be made of an insulator. Why? Because this stopper, first of all, will kind of prevent convection. will decrease the heat loss by convection. No hot air molecules would be able to move up ولا cool molecules would be able to move down. فخلاص this stopper would prevent the heat lost by convection. طيب حلو جدا. Second thing, هنا we have a vacuum between these two surfaces. Okay, this is a vacuum between the two surfaces. Why do we have a vacuum between the two surfaces? To prevent. Okay, هنا we have to say to prevent, completely prevent conduction and convection. Why? Prevents conduction and convection. Why does it prevent? Let me write it down because this is very important actually. It prevents conduction and convection. Why does it prevent conduction and convection? Because there are no molecules, no particles, okay? No molecules to move and create convection, no molecules to vibrate, okay, or touch to create conduction. خلاص, completely prevents conduction and convection. The surface, the vacuum in between these two surfaces. طب again, what else? I need the inner and outer surfaces to be made of non-metals. Okay, you need the inner and outer surfaces. Again, I'm saying this is the optimum. Okay, this is the best thing that you can do. Are all flasks or all vacuum flasks made this same exact way? لا. But I'm saying this is the optimum. Okay, so the surfaces, okay, or the material from which this vacuum flask would be made of, preferably from a non-metal. Okay, this is a non-metal or an insulator. Why would it be an insulator? Again, to reduce the heat lost by conduction. Reduce ايه يا شباب؟ reduce the heat lost by conduction. Non-metal هنا. طيب, what about the surface? The outer surface should be colored ايه بقى؟ shiny white. Shiny white outer surface. طيب اشمعنى؟ Why shiny white? Okay, or a shiny surface خلاص. Shiny surface. Why would the shiny surface be optimum? Again, shiny surfaces are the worst ايه بقى؟ emitters and worst absorbers. worst emitters and worst absorbers. So if you have water inside, if you have water or a liquid or whatever, some hot coffee inside, I want this coffee to remain hot for the most amount of time possible. Okay, I need it to remain hot for several hours. I'm on a trip or that. I want it to remain hot for several hours. طب يبقى I should color the outer surface shiny white. Why? Because the shiny white is the if it's hot, hot means that it's the worst emitter. صح? Worst emitter. طب if I had some cold water, I'm going on a safari or whatever in the desert, I need cold water. خلاص, I will add some cold water. The shiny white surface would be the worst absorber of infrared radiation. Of airship of infrared radiation. So you have a lot of keywords in this example of vacuum flasks. Okay, it actually يعني kind of revises the whole session. Conduction, convection, and radiation, all of them are in one example. Are in a one example. So this vacuum flask, it's very important. It's a very important example. You need to have several specifications for this vacuum flask. طبعا الستopper non-metal, vacuum prevents conduction convection. Why? Because there are no particles. Non-metal, why? To reduce conduction, reduce heat lost by conduction. Shiny white, because it's the best, because it's the worst absorber and worst emitter of infrared radiation. Please, of infrared radiation, never forget to say that. If you say of heat, you might lose a mark. You will, not might, you will lose a mark. Okay. حلو. حلو. طيب. um, كده احنا we're done for the heat transfer. Let's talk about the heat energy calculations and start to solve quite quickly. يلا. Heat energy calculations. Heat energy calculations. احنا we only have one equation. One equation. Specific. Okay. Specific heat. One calculation. Specific heat capacity. What is this equation? E equals mc delta T. Specific heat capacity. C is the specific heat capacity. يلا. What is C يا شباب? It is the specific okay. Specific heat capacity. What is delta T? It is the change. It's not the temperature, but it's the change in temperature. The change in temperature. What is M? طبعا it's the mass, and E is the energy. It is the energy. طيب, can I find, or can I calculate, can I find C? Yes, you can find C. C is specific heat capacity, would be E over M delta T. E over M delta T. And hence, we can find the unit of the specific heat capacity. والله, the unit of the energy is joules. And the unit of mass is kilograms. Or grams, على فكرة يعني. Kilograms or grams. And the unit of the temperature would be degrees Celsius. Would be degrees Celsius. طبعا it could be Kelvin. It could be Kelvin. Okay, خلاص, they added Kelvin to the they added Kelvin to the syllabus. So instead of degrees Celsius, it could be Kelvin. I'm saying it could. Did I have, or did I see any questions with Kelvin before? No. Okay, but maybe they could have, or they could add a question in which the unit of the temperature, in this case, in the heat energy calculation, could be Kelvin. From what we have, we can say that the unit of the specific heat capacity is joules per kilograms degrees Celsius. Joules per ايه يا شباب ها kilograms degrees Celsius or joules per grams degrees Celsius. Joules per kilograms degrees Celsius or per grams degrees Celsius. طيب, okay, that's it. Oh, that's it. يعني most of the questions he tells you find the energy lost or find the energy gained. Sometimes he'd give you to find مثلا the energy or find the specific heat capacity, but he has the or he provides you with the power. Okay, gives you the power. والله what is power يا شباب؟ والله power is energy over time. So I can find the energy by saying power times time. Power times time. Sometimes they tell you find the power, find the time taken. خلاص يبقى power times time equals ايه بقى؟ MC delta T. Power times time equals MC delta T. خلاص. طبعا we can find the power E over energy over time, or if I had voltage and current, you can say that the power equals IV. Okay, if you had the voltage and the current. So you can't find the power, or you can say power equals energy over time. In this case, PT equals MC delta T. خلاص, it's that simple. Okay, it is that simple. And what is, man, question is, what is the specific heat capacity اصلا يعني انت, you told me والله you have a specific heat capacity of something, you have specific heat capacity of an object. What is specific heat capacity, man? Sometimes I need to define specific heat capacity. Okay, sometimes he tell you define specific heat capacity. طيب حاضر, specific heat capacity, يلا بينا. Specific heat capacity. بص يا شباب, someone saying, can he give us one of the temperatures and ask us to find the other temperature? طبعا. Yes. Yes, definitely he can do that. Okay. One of the questions was in paper 2. Okay, was in paper 2. He told you, well, I have the initial temperature, I need to find the final temperature. خلاص, and you will find the delta T, you will find the change in temperature, and then add or subtract it from the other temperature. خلاص, but and it depends on the question itself. And that's why I'm saying delta temperature, the change in temperature. What, yeah, Mister? What is specific heat capacity? What is specific heat capacity? Well, specific heat capacity is the amount of energy, okay? Amount of energy needed or required. Amount of energy needed or required. Why? To increase, okay? To raise the temperature, increase the temperature. The temperature of an object. Okay? Not just an object, you have to be very specific. The temperature of 1 kilogram of an object by 1 degree Celsius or Kelvin. By 1 degree Celsius or Kelvin. Why? Because 1 degree Celsius is equal to 1 degree Kelvin. يعني if I am increasing مثلا the temperature of the air today, instead of it being 15 degrees Celsius, it became 16 degrees Celsius. طب in kelvins it would also increase by 1. It would also increase by 1. So the amount of energy needed or required to raise the temperature of 1 kilogram of an object by 1 degree Celsius. So for example, if I had 1 kilogram of water, بصوا كده, I have 1 kilogram of water, 1 kilogram of water, and the temperature of this water is 23 degrees Celsius. I need to increase the temperature to this is the same kilogram of water, 1 kilogram of water. I need to increase the temperature to how much? To 24 degrees Celsius. I'm increasing the temperature of 1 kilogram of water, 1 kilogram of an object by 1 degree Celsius. What is the amount of energy required to increase it? The amount of energy required to increase the water would be 4,200 joules. Okay, 4,200 joules, which is one of the highest specific heat capacities of any material ever created. One of the highest specific heat capacities. Water requires 4,200 joules for each kilogram. For each kilogram. That's a lot. Okay, that is a lot. على فكرة يعني. For example, aluminum. Okay, if I can recall correctly, aluminum was only 900 joules. 800 or 900 joules aluminum, which is almost 4 times less, or more than 4 times less than than the amount of energy required by the water. And that's why water takes a long time, بصوا, water takes a long time to heat up. Takes a long time to heat up. You will take a long time for to increase the temperature of the water from whatever temperature to whatever temperature. It would take a long time. But on the other hand, it will also take a long time. It will take a long time for the water to cool down from a high temperature to a lower temperature. That's why if you have a huge bowl of hot water, it could remain hot for a very long time. And I'm talking for hours. For hours. Specific heat capacity of water being very high, well, that's a blessing. That is a blessing for the water to have a very high specific heat capacity. Okay, it can keep its temperature for a very long time. As humans, we know that us humans, we are made up of more than 70% water. صح؟ We're made up of more than 70% water. This water has a very high specific capacity. Yes, and that's why we can keep our inner core temperature. Okay, our inner core temperature will remain constant for a very long time unless we become hypothermic or hypothermic. Yes, that's unless that's after a very long time. Okay, but يعني our bodies are made of mostly of water, and that's a blessing. Why? Because the water will keep its temperature, will remain constant. The temperature will remain. Okay, you need too much energy to be taken out of you, or too much energy to you need to absorb a lot of energy for you to increase or decrease your core temperature. A specific heat capacity of water, 4200 joules per degrees Celsius, per kilogram degrees Celsius. That's the specific heat capacity of water. Okay, 4200. One of the highest specific heat capacities ever. حلو. حلو. Can we start solving? Yes, we can. Let's open up paper 4. Okay, let's open up paper 4 يا شباب and start solving um, heat transfer and heat energy calculations. Okay, now I'm opening up paper 4. يلا. Heat transfer. Okay, heat transfer. Oh. Okay. Oh, can you all see it now? Yeah. Page 330, 383. 383. Can you all see it now? Okay, يلا بينا. Any questions before we start? يلا بينا. Thermal energy is conducted through all solids by lattice vibration. Describe one other way in which thermal energy is conducted through copper. خلاص, he talked about lattice vibration. He talked about the conduction, lattice vibration. What is one other way in which we can conduct energy through the copper? والله by the free moving electrons. صح? You need to say, والله you have free moving electrons. What do these free moving electrons do? They gain energy. صح? They gain energy and move throughout the copper. صح? And they hit the copper molecules. يبقى free moving electrons. Free moving electrons
البيج كام؟
gain 383. Okay, gain kinetic energy or gain heat energy and move between the molecules. You have to say that, between the molecules. That's okay. They collide with other molecules, increasing their temperatures. Okay, يعني whatever you want. Okay, they take the temperature, or they take the heat from the higher uh, um, temperature to the lower temperature. Okay, يعني as you like. Okay, ماشي. The outside surface of the cooking pan is kept clean by regular polishing. Explain one other advantage of keeping the surface of the pan shiny. طيب حلو. If the surface of the pan is shiny, this is good. Why? Because shiny surfaces are what? Poor, yes, bad emitters of infrared radiation. This is a hot pan. خلي بالكوا, this is a hot pan. I want the water inside the pan to remain hot for a longer time. So you need the outer surface to be shiny white. Why? Because it's a poor emitter of infrared radiation, which reduces, okay, the heat lost to the surroundings. Yeah. Poor, okay, emitter of infrared radiation. Why is this a good thing? Allah, it keeps, okay, it reduces the heat loss to the environment. Okay, يلا بينا. The thermal energy passes into the water through the base of the pan. Identify the main method by which the thermal energy is transferred throughout the water. Okay, throughout the water. طبعا if I'm talking about the water itself, it's by convection. صح? I'm talking about the water itself by convection. Okay, yeah, that's easy. Moving on to the previous question. C, A, and B. Okay, so let's start off with A and B. State and explain. What happens دلوقتي I have a radiant
مستر
heater.
هي آخر answer كانت convection.
Yes, convection. Okay. Yeah. دلوقتي I have a radiant heater. State and explain what happens to the pieces of the cork a few minutes after the heater is switched on. Okay, I switched on the heater, this radiant heater. I have two corks on either side which are attached using a piece of wax. صح؟ طيب what happens بقى to the pieces of corks after a few minutes؟ والله the pieces of cork يعني they will fall down. صح؟ تقولي they will fall down. Why will they fall down? That's the question. Okay, يعني which of them will fall down first? Which of them will fall down first? طبعا the one um on the black side, صح? On the black surface, which is on B. صح? You can say that the dull black surface is the best absorber of infrared radiation. صح? It absorbs infrared radiation at a faster rate. We'll say that. الكورك on surface B, صح? On plate B, on plate B will fall down first. Will fall down first. Why? Because the black surface, okay, black surfaces are, in this case, you have to say it's the best absorber, or the best absorbers of infrared radiation. Infrared radiation. Okay, you can say that the wax will melt, for example. Okay, the wax will melt faster than on plate A. Okay, يلا الواكس melts faster than plate A. يلا 4 marks. Okay, يلا question B. Give the name of the method of transfer of thermal energy in solid metals. In solid metals. Okay, what's it? Conduction. Yes, conduction طبعا. So apparently this is another question other than the other one. يعني this is completely different. But still, let's solve it. Some surfaces are better at emitting radiation than others. Describe an experiment to show whether black surfaces or white surfaces are better emitters of radiation. يلا better emitters of radiation. يعني ايه better emitters؟ دلوقتي أنا I need should I use بقى the one with the hot water inside the tank ولا should I use the one with the cold water? لا, this is an emitter. This is an emitter, so you need to use hot water because it will emit heat to the environment. So basically, you need You may draw a diagram. طبعا you don't need to draw a diagram, but you may. I'll draw the diagram so that you can understand what I'm doing. Yeah, this is hot water. صح? Hot water. And this surface, let's say that this is it's shiny white. Yeah, shiny white, and this surface is dull black. Dull black. And you have thermometers on each side with equal distances. يلا. Okay. يلا. Distance هنا D and distance D. يلا. Equal distances. They have to be on equal distances. هنقول له والله when thermometers are at equal distances, what happens? التhermometer near near the dull black surface would have would have a higher temperature. Why? Because the dull black because the dull black surfaces are the best emitter surfaces أو best emitting surfaces أو dull black هنا is the best emitter is the best emitter of infrared radiation of infrared radiation يلا hmm. You can say that we have equal distances on each side صح same time same يلا To ensure that the conclusion reached in the experiment is correct, several details of the experiment must be identical while testing the two different surfaces. I just said them. Yeah, two quantities that must be identical during the test. يلا, I just said them, صح? Same temperature of water. You're saying, someone saying, same temperature of water, same volume of water. If I want to repeat the experiment, again, yes, you need that. Okay, if you want to repeat the experiment two times, you need to say, for example, yes, same initial temperature of the water, same volume of the water, same time left, صح, same, for example, if you had a lid or no lid, and these are all on same initial temperature of the thermometer, ماشي, or you might actually mean same room temperature. You might say same room temperature. فيعني yes, I'll go with the easier answers, which would be same initial temperature of water and same volume of الwater برضه. طيب ها سهل الكلام صح easy. هو يعني to be honest يعني these questions are that easy يعني when you have questions regarding the heat transfer he doesn't have that much to ask about. Okay, he doesn't have that. It's either conduction, so you have to state lattice vibration or free moving electrons. It's either convection, hot air or hot water moves up and cold water moves down خلاص, or radiation, and you have to say, you must say يا شباب, okay, please, you must say infrared radiation. Okay, because I've seen a lot of students have lost too many marks because they forgot to simply write down infrared. They said radiation. Okay, so they lost 1 mark. Yani infrared radiation 2 marks. If you say, for example, best emitter of heat, you lose 2 marks. The best emitter of radiation, you lose 1 mark. Best emitter of infrared radiation, you might gain the 2 marks. Okay. ماشي, let's solve this question. Explain why houses in hot countries are often painted white. In hot countries, why do we paint the houses white in hot countries يا شباب؟ والله because الhot أو white surfaces are ايه بقى؟ white surfaces are best ولا worst؟ لا, hot surface white surfaces are الworst are the worst. Can I say emitter? لا. You can't say emitter. Why? Because the house needs to be colder than the environment. So white surfaces are the worst ايه بقى؟ absorbers of infrared radiation. Infrared ايه؟ radiation. You can say worst absorbers and best reflectors. صح؟ You can say both. Okay? Can I say absorber and emitter? لا, don't. If you're not sure, if you're not sure, okay, say. بس يعني that would mean that you don't actually understand it quite well. Okay? It would mean that you don't actually understand it. You don't fully understand the question. Make sure that you know the difference between absorber and emitter. When should I say an absorber and when should you say an emitter? Okay, so for this case, you have to say that the white surfaces are the worst absorbers of infrared radiation. They decrease the amount of infrared radiation absorbed by the house. A star approaches the end of its life. So someone's saying he didn't say shiny. How can I say reflection? Um, you're not wrong. You're not wrong. And if you don't want to say reflection, okay, you can just ignore the reflection. Okay, I'm saying if you want to say best reflectors, but you're not wrong. You don't have to say reflectors. You don't have to say, oh, I'll just remove. But you don't have to say reflectors. That's okay. As a star approaches its the end of its life, the amount of radiation emitted from it per second changes. The star cools down. It's dying. State any effect on the rate of emission of the radiation. Rate of emission. Yeah, Mister. What does space physics has have to do with this question? It has to do nothing. Nothing. He's saying the star is cooling down. The star is cooling down. What does this, or how does this affect the amount of radiation? How can this affect the amount of radiation? Well, the amount of radiation would decrease. That's it. Yes, it decreases. يعني it decreases. والله the amount of radiation is affected by the temperature. It's affected by the temperature. It's affected by the surface, خلاص, the color of the surface, the roughness or smoothness of the surface. It is affected by the volume or the shape of the surface. يعني if you increase the surface area, if you increase the surface area, then it would, or the rate of transmitting this infrared radiation would increase. Okay, the emission of this radiation would increase if you increase the surface area. Okay, so temperature is a really, really, really important factor that affects the rate of transmission of, or rate of emission of heat. طيب هنا we have all of the questions about almost the يعني basically the same questions. Okay, basically the same questions. وهنا this question was talking about the sun. We will talk about the convection شوية. We'll talk about how the هنا the sun, how the sun transfers heat to the earth. والله through the vacuum it will be transferred by infrared radiation. When it reaches the earth it would be absorbed. خلاص. طيب هنا when he was heated, or some of the heat while he was driving by the beach, he felt the breeze of air. Why? Because of convection. Because of the convection, so the hot air above the road rises up, but the cool air uh, from the uh, uh, from the sea comes in. This is the cold air. It's coming in. Why? Because the hot air is rising up. The hot air is rising up, so it has to be filled up by cold air coming from the sea. طيب حلو. حلو. Let's move on to questions, the other questions regarding the calculations. Let's move on to the calculations questions. خلاص, this is the last couple of pages in the book. Yeah. Last page, page 413. يلا بينا. This is part B. في part A هنا؟ لا, مفيش part A. So, let's solve it. يلا يا شباب. The mass of water in a bottle is 0.18 kilograms. The specific heat capacity of water is 4,200 joules. Calculate the thermal energy needed to increase the water by 20 degrees Celsius. You need to increase the
مش فاهم يا
temperature.
مستر.
يا جماعة يا حبايبي last page 413. Okay. Okay. Thermal energy E equals MC delta T. صح؟ يلا. اوكي E equals MC delta T طبعا 0.18 هنا خلاص او straight forward 0.18 times 4200 times ال delta T is 20 خلاص يعني let's write it down كده هيطلع كام؟ 0.18 times 4100 times 20 is 15,120 15,120 joules. You can write it down as 1.5 times 10 to the power of 4 joules. Okay, you can write it down. Yeah. حلو السؤال ده. Calculate the pressure difference between the top and the bottom of the water. Yeah, this is a pressure question. It is a pressure question. It's an easy pressure question. عادي خالص. You have the height of the water, you have the density of the water, you have everything. صح? So how can we calculate the pressure? Rho G H. صح? Pressure equals rho G H. طيب يلا calculate rho G H هيطلع كام؟ يلا pressure equals rho GH. What is the rho? What is the density? 1000. 1000 times ال G 9.8 times ال H 40. لا, it's not 40 centimeters. It's 40 ايه؟ ها? It's not 40 meters. It's 40 centimeters. So you need to convert it to meters. This would be 0.4. صح؟ Times 0.4 is 3,920. 3,920 pascals صح؟ can you all see the screen يا شباب ولا طب if you can't see the screen مش عارف try to refresh ولا حاجة أو okay okay previous question C وهنا B so we can solve it من هنا we have this aluminum block leaving the furnace. The mass of the block is 1,200 kilograms. It's heated in the furnace from 22 from 20 what and you have a question the difference هنا hey it's 3,920 pascals. The difference between the height the top and the bottom the difference between the height the top and the bottom would be 3,920 pascals. يلا the mass 1200 it's heated from 20 to 380. The specific heat capacity is 960. Oh, 960. Calculate the thermal energy gained by the block in the furnace. Can I find the amount of energy? Allah, yes, it's the same. صح? The amount of energy would be the same. E equals mc delta T. يلا E equals mc. يلا الماس 1200 times C 960 times delta T the change in temperature 380 minus 20 380 طبعا this would be a huge number يلا 1200 times 960 times 360 4 يلا this, yeah, we have a lot of zeros ادي 3 zeros ادي 3 more zeros 400 million 400 million. So this is basically 4.15 times 10 to the power of 8 joules into on your calculator. This is 414,720,000. So it's 414 million. We can write it down as 415 million. أو يعني 4.15 times 10 to the power of 8 joules. It's a huge number. The factory worker is standing 3 meters away from the block. State and explain the main process by which the thermal energy is transferred to the worker. يلا. The main transfer of energy. Huh. Can you say conduction? 4.1 times, and I want to write it 4.1 times 10 to the power of times 10 to the power of 8. Okay, 4.14 to be more accurate, times 10 to the power of 8, or 4.15 in this case. The main process by which the thermal energy is transferred to the worker, could it be by conduction? لا طبعا, it's not by conduction. Huh? Yeah, it could be يعني انت, he could receive some of the energy by conduction, yes, but is it the main, hmm? Is it the main process by which he can feel the heat? لا, it's not the main process. Huh? By which process طبعا? By infrared radiation. By infrared radiation. Why? Because he's not touching the surface. صح. If he was touching the surface, then طبعا it would be by conduction. طب is he above the surface? Is he above this hot block? لا, he's not above the hot block. If he was above the hot block, he would be heated up by convection. لا, he's standing next to the block. Next to the block. So infrared radiation is absorbed or is emitted by the block, okay, and is absorbed by the worker. That's it. Infrared radiation is emitted by the block and absorbed by the worker. سهل الكلام. يلا. Radiation. Okay. يلا بينا. Infrared radiation. Okay. 2 marks. Infrared radiation. And then absorbed by the worker is worth 1 mark. يلا. Infrared radiation is emitted by the block and absorbed by the worker. طيب. State and explain the main process by which thermal energy is transferred from the outer surface of the solid to the interior. To the interior. To their interior. طيب يعني throughout the own block, throughout the same block, inside the block, the heat is transferred by conduction. صح? It's transferred by conduction. طب this is a metal block, this is aluminum. يبقى we can say conduction and free moving electrons. صح? You can say both. You can say both. And you can explain both if you want to. This is a 3 marker. So basically, and if you have a 3 marker, you want to say 2 processes and explain either of them. I will say conduction, okay, and free moving electrons, which move freely or fast between the molecules, transferring the heat. Yeah, transferring the energy. ماشي؟ سهل الكلام ولا ايه؟ يلا, one last question and I'll let you go free. Yeah, that I have a kettle. Power rating of this kettle is 3 kW. 3 kW. Someone saying, should I say vibrates? Yes, you can say. You can say, and you can explain the vibration of the solid because it's conduction, okay? Or you can say what happens in the free moving electrons, and say as much as you'd like. The kettle has a power rating of 3 kilowatts. kW is what? This is kilowatts. Calculate the energy supplied. Electrical energy. طبعا electrical energy we can find it using this very simple equation. E equals VIT. VIT أو power times time. Power times time. طيب VIT يعني الفولتج is أو power times time. Do you have a power? Yes, I have a power. Power times time. What is the power? 3 kilowatts, 3000 watts times time, which is 3.5 minutes. So you have to convert it to seconds. Okay, you have to convert it to seconds. This would be 630,000 joules, or 630, you can say, kilojoules. Okay. Hmm. Okay, يلا بينا. In these at 3.5 minutes, the temperature of the water reaches 100 degrees Celsius. Initially, the temperature of the water, بص يا شباب, initially the temperature was 19 degrees Celsius. The specific heat capacity of the water is 4,200 joules. Calculate the energy gained by the water. Okay, ايه ده؟ energy gained. طب E equals mc delta T. mc delta T. يا مستر احنا we don't have the mass. Do you have the mass? لا, we have the volume and we have the density. Can I find the mass? Yes, the mass would be يلا mass. والله density equals mass over volume, so mass equals density times volume. صح. Density is 1700 joules, and density is 1 gram per centimeter cube. صح. Density صح, 1 gram per centimeter cube, which would be 1 يعني, so the mass is 1700 grams. 1700 ايه grams. E equals mc delta T. الماس is 1700 grams, بس C is 4200 kilograms أو joules per kilogram degree Celsius. So you need to convert. You have to convert. In this case, على فكرة, most questions you wouldn't be required to convert. But in this case, you have to convert. Why? Because the mass is in grams and the C is in joules per kilogram degree Celsius. The easier way is to just simply convert the mass into kilograms divided by 1000 would be 1.7 kilograms. So we have the mass, we have the specific heat capacity. Do we have the temperature? يا شباب, the temperature isn't 100. The temperature, this is the final temperature. What was the initial temperature? It was 19 degrees Celsius. But don't forget about this. That's why this question is worth 5 marks. 5 marks is a lot. 5 marks is a lot. يبقى احنا we have a lot to do in this question. طيب, الماس خلاص 1.7 times C 4200 times الدلتا T, which is 100 minus 19. صح, minus 19. This would be يعني 81. Yes, that's the delta T. this هيبقى كام? 580,000 joules. صح, gained by the water 580,000 joules, which is 580 kilojoules. صح. ماشي, يلا. Calculate the efficiency of the kettle. Efficiency equals useful power output, useful power output over total power input, or useful energy output over total energy input. Do we have output and input? Yes, we have two numbers, 630 kilojoules, 580 kilojoules. Which of them is the input and which is the output? يا شباب, I told you دايما always the larger number would be the input and the smaller number would be the output. بس كده. Yes, that's it. The larger number would always be the input. يعني هنا 630 وهنا 580. We can multiply by 100 to find the percentage. So this would basically be 92%. Okay, 92%. يبقى total input larger number, useful output smaller number. Okay. طيب. The questions are almost all the same. يعني all of them would mostly be the same because he would give you energy. على فكرة بصوا, while solving, okay, this is for your own good. While solving, if you have any questions regarding something called the latent heat, it's cancelled. It has been removed. If you have any questions regarding the heat capacity or thermal capacity بس, يعني if I say heat capacity. أنا in this lesson I was saying إيه specific heat capacity. طب if another question was asking you to find the heat capacity alone, بصوا heat capacity or thermal capacity, okay, or whatever latent, okay, latent heat of fusion, latent whatever, okay, these are all cancelled. They have been removed from the syllabus. They have been removed from the syllabus. So okay, just يعني this is for your own sake. تمام. طيب حلو أوي.